Well, this next session, we're going to do this radio. Picked up this Zenith radio here. Look at how beautiful that thing is. I mean, whoever did that woodwork, that's just like a piano finish on that thing. It's, I don't know if you can see how the shine is on that thing. Look at that shine. I mean, it's absolutely like a piano finish on the whole radio. And I got it for $55 at an auction. And there's a catch to it, of course. It's a farm set. A farm set means that it's a radio that was used on the farms that didn't have electricity. So they made it to work off of a battery. So this one has got a vibrator and it works off a 6-volt storage battery. And the people on the farm would be able to listen to it using the battery for power. And then each weekend they'd take the battery to the filling station, wherever they were, their gas station. And usually the gas stations would have electricity and they could charge their battery. But for us, we're going to go ahead, we're going to convert it to regular old wall socket. We want to be able to just plug it in and have it work. It's too beautiful of a radio to just have it sit on a shelf. Now, the person who did all of this fine cabinet work and stuff had no electronic capabilities at all. So things are just left. The speaker is open. I've measured that with an ohm meter, and it's open. It's a permanent magnet speaker, I think. It's a permanent magnet speaker, but the transformer on there, the audio transformer, output transformer, is open. So that's got to be swapped out. And then there's the wires that go to the grid caps are just hanging loose here. You've got to put a clip on them. And all right, that one's bad. That's no big deal. We got plenty of them out there. These are just pull-offs. Okay, these are nice knobs, but they are not original Zenith knobs. These knobs are reproductions. It's a beautiful radio, that's for sure. When it's working, it'll bring $200 or more. $55 was a very good price for it. All right, there hasn't been any work done electrically. You can see all the capacitors and stuff are original crap. All right, the thing that we have to consider that's most important is this right here. This is the vibrator, and this is the vibrator transformer. So what we got to do is get this, this, and this off of here. It's all junk. Okay. We'll make it. Hey, it's got a new dial cord on it. The guy did all of the cosmetic work just fine. Kind of sloppy at the transformer. It should be black. And there's the vibrator. Okay, we won't need that. Okay, now what we'll do, we'll grind this out. We'll put us a standard octal socket there for a 6x5 tube, and then this will be a standard transformer. Now the filter capacitors in complete junk, no doubt. $20 mics at 150 volts. Boy, that's going to leak like hell. Junk. Okay, let me get this. Filter choke. Why would he tighten it that damn tight, huh? I'm gonna have to go get a ratchet and a socket. Whoever that idiot, you know, you get people that don't understand tightening nuts and bolts, and they tighten them to the point to where the metal stretches. All right, okay, I'm gonna go and get a power transformer, an octal socket, a wrench, okay, and an audio transformer. God damn. I don't know what the hell. I mean, that idiot, he tightened that down until the metal stretched on the screw. I mean, I've seen these people before. They'll twist a screw off or a bolt. All right. All right, that's the filaments. So that definitely doesn't go there. Let's see, that's that filter capacitor. Cut that directly. Where? Big screw. Hmm. Now, that's the existing transformer. And here's the replacement. Hey, how about that? Chuck, okay? This way. Oh, shit. Oh. Nothing ever is easy. Look at that crap. The other transformer brought all the wires out on one side. This one's got them coming out on both sides. So I got to drill a damn hole in there. Oh. Shit. All right, that gets us a hole in there. Well, one of them went out. A little more oomph here. Let's use this one here. All right, let's try. There we go. If I go diagonally, that'll do it. Okay. That's not a number 6. Okay, that gets us transformer and the tube. Okay, so now those are going to be the high voltage, I'm sure. Okay. Okay. Now the line Okay, that's one. Now I got to get from the other one to ground. Okay. That's the high voltage and the filament. Pin 8 is going to be, okay, the next thing we've got to do, we need to put a line cord on here. Look. At it, okay? Yeah. The switch is not working. Oh, good. Typical, just typical. All right. See, you drill a little hole into the side of the switch, spray the contact cleaner into it, and then it'll take care of it. All right. Now, I've got two. These wires here are supposed to go onto here. These are clean, but we want to steal. Okay. All right, now I need to squeeze. Get here. Okay. All right, that takes care of all our grid wires. All right, first thing we're going to do is just check the B+. All right, let's see, 250 volts. Okay. No, I'm getting it. I'm getting 220 volts. Okay. That was a good one. I didn't test this one. I don't know if this one's any good. I will test it right now to make sure. Ah, that's okay. It's good. go to here, I should hear scratching noise. Okie doke. Capacitor could still be charged. Alright. Okie doke. Now, if I power it up and touch that grid, we should get a buzz out of the speaker. Shitty sounding speaker. Now, there was another situation here. What they did in this radio, the two front end tubes hooked in series with a resistor and a pilot light, and that went to 6 volts. This was a 2-volt pilot light, 2-volt tube, 2-volt tube. That made 6 volts, and they put a small resistor in there to limit the current, surge current. And that went to the 6 volts. Okay, we're replacing these with 6-volt tubes. Okay, that's 6 volts, 6 volts. So we're going to connect them in parallel. And that's to 6 volts. Get rid of the crazy stuff. All right. The crappy speaker, I think it's got a loose cone. Ain't working. See, when we connect this antenna wire here, we should get scratching noises, but we're not. Okie doke, well, we'll have to see what's wrong. Now we got the pilot light lit up full brilliance. Okay, this is the oscillator coil. I don't know that it's any good. We will find out. We're going to ohm it. I got this to the ohmmeter. Ohmmeter now. I've got one terminal on the oscillator coil. Doesn't look like it has any connection to it. Alright, we're going to hook one to ground. This is signal generator. And we'll hook one to the antenna input. Alright, got the signal generator hooked to there. I'm going to set the generator to the AM band. Okay, megahertz. Okay. Okay, we'll go right there. Okay, now what I have to test the input circuitry, I've got the signal generator connected straight to the antenna terminal, and I've got the scope connected to the grid of the converter tube. Okay, if we look at the scope, now observe as I tune the radio. Okay, we go on, we can see that we're tuned onto it, okay? Okay, that's off. That's on. Off as much. Okay, so we've got the antenna circuit completely intact. The next thing we do, we're going to fire it up, and we're going to see that the oscillator itself is running. All right, I turn the power on, and we let it warm up. We do not have any oscillation. We should have oscillation there. That's what's wrong with the radio. We do not have oscillation on the oscillator. All right, this is the oscillator coil. All I was doing is putting the scope probe next to the oscillator coil, and we should be able to pick up the oscillation on the scope. We picked nothing up, so the oscillator is not oscillating. So what we have to do is test, look for voltage and stuff like that. All right, I'm going to get the meter. And I'm going to set the meter to 250 volts. And we'll hook one to ground. There. Okay, now, pin 2 is the plate. We've got no voltage at all. 3, screen. Okay, the first thing we have to do is test the voltages on the tube. Okay, pin 2, we've got no voltage at all. Okay, 3. Okay, we got 70 volts, which is correct. Screen. Grid, we got nothing but a little bit of positive. Okay, and the filaments don't matter. Okay, we don't have any B+. Okay, we've got a connection broken. It's like that IF can is fucked. I see screws have been loose, so I suspect they've damaged these IF cans. Oh boy. Wonderful. Oh God. He's fucked every one of the IF cans. Yeah, it just, you hope this stuff's going to be good, and none of it is. It's the IF can is completely shot. When the idiot took these cans off to paint them, he broke the wiring inside, no doubt. Hell, all I can do is get after it. It's either that or scrap the radio, and it's too beautiful a radio to scrap. I can see now why I got the radio for $55. Whoever worked on it knew that all the IF cans were shot. Alright, let's see what we've got here. Oh boy. Oh boy. I don't think it was him. I think let me get this out of here. We got work. There's been rodents. There's been rodents. If you look here, see the chew marks? Chew marks from where rodents... Okay, here's coil number 1. Okay. Alright. Both are shot. Okie doke. Oh, God. I thought it was going to be easy. I didn't see on here any chew marks on there. There's no chew marks on the... No connection. Okay, the oscillator coil has definitely got something. Something is screwed. Really don't see any chew marks on there. Good. Well, that one's good. Alright. I wasn't getting the right ohms. I wasn't measuring the right ones. Okay. We're okay on this one. Okay, that one's okay. So I just have to find a coil for the other one. Okay, I see where the problem is here. You can see a path. You can see a path on this coil here. This one's supposed to go to this top coil. Oh boy. Okay, I've got to go get another IF can. Okay, that's a single in the center. Okay, I can do that. The coil in this other IF can was shot. So I had to remove so much of the coil to get to good. See, a rat had been chewing on it. So no good. But I have another IF can right here, and this is no doubt a 455. So let's fire up the scope, and we got the generator going, and I want... This is a Keysight scope, which is renowned for its long boot up time from power on. Takes it about a minute or so. Stick the generator. Okay, one coil. And scope is going. And I'll connect scope to the other coil. Whew, there we are. Okay, now I've got one of the coils hooked to the generator and the other one hooked to the scope, so we can see the see as I vary the frequency. Okay, that's the peak right there. Okay, and that's reading 382 kilohertz. And if I take a screwdriver and turn the screw, okay, now I'm going to adjust. I'm going to go there. Okay. Okay, that's reading 470, so that's got plenty of range. Okay, so this is a good transformer. Okay. Damn thing's hot. Okay, this goes like that. Okay, we do not have a wire out the top here, so we just stick this in there in the old which way. Alright, now, ohmmeter. Top of the coil. Okay, the place where the rat ate it is the top of the coil. As a matter of fact, I see it. There's the wire right there. Now, that one has to go over to there. Okay, I pull that off. Okay. Now, what I have to do, you can pull turns off of there. You know, if you have to pull a turn or two, it doesn't matter. You've got enough adjustment on the thing to take care of it. You've got to pull more than 5 or 6 turns off of it, then you'll have to rewind it. But one turn has no effect at all on it. Next, we measure from this coil, this point here to here, we get it. And if we go from here to here, we get it. All right, now that fixes the oscillator coil. Power on. All right, got the power on. Okay. That's odd as hell. We've got good coils now, but we don't have any oscillation. Well, that ain't worth a darn. Okay, now, we were not getting any oscillation, so this one resistor here in the cathode. Okay, here's the circuit right here. We've got the oscillator coil here. The feedback coil is in series with the IF output can, because we're using the same tube for the oscillator as we are the converter, the mixer converter. So it oscillates, plus the signal is put to the grid, so that makes it to where it inherently serves as a mixer. Okay, and that gives us our AF. But we're not oscillating. So what is wrong? Okay, we have our tuning condenser, our coil. We already know that's correct because we hooked the signal onto the feedback winding with the generator and then looked at this with the scope, and it tunes properly. All right? Now, the place where the problem is this resistor right here. That is reading way high. So I put a potentiometer on it and adjusted it, and now I'm going to increase the value of the resistor, and you see when it's open or just effectively not in the circuit, we don't get any oscillations. Now I'm going to bring that value down, and all of a sudden, bloop, It oscillates. Okay, I'm going to go ahead and I'm going to increase it a little bit. Now I'm going to adjust it over the frequency range. All right, that's the lowest. Okay, and that's the highest. So we go with that value of resistor. We oscillate over the entire range. Now what I want to do is, the power is off, so I'm going to measure the value that we've got here. All right, 2.2K is what we need. Okay, there we go. Okay. All right, that gets us oscillator. Now, the next thing to do, we're going to feed a signal in and tune the IF. Okay, let me get a piece of wire to hook to the antenna, and we shall... I don't know if we'll pick anything up or not without tuning the thing up. Where'd my antenna wire go off to? Hi there, baby. Hi there, kitty. I knew you'd want to come in. 100 degrees out there. My poor little kitty's been out there in that hot. Oh, that poor little baby. Yes. Isn't she pretty? Yes, she's a pretty kitty. You can supervise. Now, this is the generator that we've got set up. AM modulated with 455 kilohertz and a frequency of around 500 hertz for the modulation. Okay, and we're going to connect that to the antenna. Now I want 455. Okay, we've got it set to 455, and now it peak up. That's pretty good. Okay. Damn. Woo! Picking something up.
News, gossip, and thought of the enemy, and were else their Democratic opponents. And the thing, and the problem with that is that all right. 70% of all clicks, according to one study,
okay, the radio
on
works.
The first 6 results of page 1.
Generator off, antenna on, and
climate agenda. We've been trying to make appliances more efficient for 50 years, and all we've done is make them more fragile. The dishwashers are washing. With jobs like that, and you haven't been.
Okie doke. That gets it working. I don't know. I guess it was just the electronics. Alright, it's okay. The speaker is completely intact. Let's see. Go. Yeah. Right. There we go. Okay. Okay. Now the antenna. Just going to put a. Alright, and that gets our antenna. We got it. One, two, one more. Come on, there's got to be one more. One more. Alright, we've got two original knobs. Okay. I've got to find one more knob. Okay. Power on. That is a really nice looking radio. Not good. Okay, we've got okay, let's see. something's wrong. It was a shit of a lot more sensitive.
He struggled defensively. Now he had the throw out the other night, which was really ironic given the nod that was called not in favor of the Rangers, and all you got to do is listen to their broadcast crew to hear how unfair life is. But we were talking about the lineup earlier. It just there's almost on a daily basis.
Kelly back tomorrow night. Did you get a look at Hunter Biden when he walked?
One capable of winning 11 or 13.
Because we found out when she asked the prosecution.
All right, good enough. Good enough. That's it. All right, that's a gorgeous radio there. Gorgeous radio.